We're on Desmos topic 12. Going to apply Desmos to topical polynomials. Just take these on menu. We're going to review some division here. Division of fractions. We have 45 divided by 7. In the decimal form, it gives us this. If we write 6 plus 3/7, because 7 goes into 45 6 times, and there's a remainder of 3. So these two give us the same value. So whether we write it like this or we write it like that, we get the same answer. However, you can't write 6 3/7 like this in Desmos, because what it does, it translates it as 6 times 3 divided by 7, or 18 over 7, which comes out to be this. So this is not equal to this, nor is it equal to that. So just be careful of how you write things. If we set a equal to 3, and we have 6a plus 6 divided by a plus 1, we get 6. Because this would be 18 plus 24 over 3 plus 1, which would be 4. 24 over 4 would give us 6. Now we could also write this, factor out the 6, use the distributive rule. 6 times a gives us 6a, and 6 times plus 1 gives us 6. So what we've written in box 5 and what we've written in box 6 are the same, and so we get 6 here. Both mean the same thing. If we go one step, we take 6a plus 7 divided by a plus 1, and we get 6.5. We could rewrite this. This goes into this 6 times, but there's a remainder, 1 left, so we get 1 over 8 plus 1. So this and this are the same thing. Now, we go to more complicated functions, such as page 16, number 20, this problem. We're going to use in Desmos at 8 to 4. Remember, we can't put this in because Desmos won't recognize this, give us an error message when the power of x goes to high. So we're going to put it in, just replace the x with the letter a, but this expression is identical to this one. And if we do that, we get 24.08 when a is 4. Now, what I did was, I did the long division on this. You can go back to page 60, number 28. This is what it gave me, and the remainder was 6a plus 3 over the denominator, this. I get the same answer here. So I know this is equivalent to that. I know this is not very elegant, but it is a way of verifying answers. So if you go back to this problem here, you'll see that I got this as the answer. When I divide this into that, of course replacing the x with the a, I get this and this as the remainder. So it is a way of checking it. This one here, page 59, number 20, same kind of thing. I divide this into this, I get this, and here's the remainder. This equals that. Now you should always vary the value of a to make sure that these two numbers stay the same. So use your slider under a. Here's the slider. You can do that. Remember, this is a frozen form of Desmos. It's not an active form of Desmos. So finally, here is a third problem, page 60, number 32. Quite a long, complicated one. It's a little faded here, but this is a 6, this is this, and the denominator here is this over here, and get exactly this. So you can see that this number and this number are the same. So, way of verifying. Now, just a little aside here. Under the older version of Desmos, version that I'm using is a newer version. If I take this problem right up here, is it, yeah, it's this one here, page 60, number 28, and I put an equal sign in and write this. Under the old version, you got the number 1 here, meaning that this was the same as that. If it was not equal, you would see undefined here. Now, Desmos has, in the newer version, doesn't have this ability. You can't write this expression equal to this. You won't get this. It won't accept it, and that's all. It won't accept the equal sign, so you get an error message. So an aside of changes that have been made in Desmos. That completes page 57 and its application to division of polynomials.